we start off by saying, or by mentioning, what active return is and what active risk is. So active return, we say, refers to the differences in returns, refers to the differences in returns between a managed portfolio and its benchmark. A managed portfolio and its benchmark. Take, for example, we are using the benchmark as the NSE 20. It generates a return of X. Then we have our hypothetical portfolio, that we have allocated specific weights to specific asset classes. We get return Y. So we're saying the active return is just or refers to the differences in returns between a managed portfolio and its benchmark. So we just say Y return minus X return, and that gives us active return. Moving on, we can say that active return is therefore return on the portfolio minus return on the benchmark. RP portfolio return, RB benchmark return. So that is it, active return. What then is active risk? So we say active risk, active risk, active risk, active risk there. We can also say is also termed as tracking error, tracking risk, brackets, tracking error, stroke, tracking risk. There. So we extend that line until there to refer to it as the same thing. Is the standard deviation of active return. Is the standard deviation of active return, is the standard deviation of active return, So we dive right in to the formula. It is given as follows. We can come on this other side. We're not supposed to strain as analysts or as experts in the financial services. So active risk is given as standard deviation of return on the portfolio minus return on the benchmark, subscript, which then can be expounded as follows, as return on the portfolio minus return on the benchmark divided by n minus 1, where n is the number of periods. Return on the portfolio, we've already defined that there, return on the benchmark. So this is what we're saying is active risk, standard deviation of active return, like that, standard deviation of active return. Standard deviation of active return is what is termed as active risk. So we can say that the active risk of a portfolio a portfolio can be separated into two components, full colon there. Number one, active factor risk, and we are saying is attributable to the deviations, to deviations of the portfolio factor sensitivities of the portfolio factor sensitivities versus the benchmark versus the benchmark sensitivities to the same set of factors, The active risk of a portfolio can be separated into two components. Active factor risk, which is attributable to the deviations of the portfolio factor sensitivities versus the sensitivities of the benchmark. So there's benchmark sensitivities to the same set of factors. The second component, number two, active specific risk. Underline it for consistency. You put a hyphen and say risk from active asset allocation, risk from active asset selection, active asset selection, risk from active asset selection attributable to the deviations, attributable to the deviations of the portfolios individual asset weighting, individual asset weighting versus the benchmark versus the benchmark's individual asset weighting, after controlling for differences, controlling for differences in factor sensitivities, factor sensitivities we can say of portfolio versus the benchmark, of portfolio versus the benchmark, Let's review what we've just written there. There are two factors, active factor risk, active specific risk. We're saying that risk from active asset selection attributable to the deviations of the portfolio's individual asset weighting versus the benchmark's individual asset weighting after controlling for differences, because there'll be differences in factor exposures or factor sensitivities, in factor sensitivities of portfolios versus the benchmark there. So having discussed that, then we can move over on this other side and discuss something else. The sum of active factor risk, ladies and gentlemen, the sum of active factor risk, the sum of active factor risk and active specific risk, active specific risk is equal to active risk squared, active factor risk, active factor risk plus active specific risk, active specific risk. So this is a very important equation right there. You're saying that the active risk squared is active factor risk plus active specific risk there.